Math 83, Unit 4, Lesson 2. We're going to factor a trinomial of the form ax squared plus bx plus c, where a is 1. And if I take our trinomial of x squared plus 24x plus 44, and I wanted to find my a, b, and c, well, a is the number in front of x squared, or the coefficient of x squared. And you can see here that our coefficient is 1 of x squared. Our b is the number in front of x, which in our case here is 24. And our c, or our constant, is 44. So we're going to learn how to factor trinomials that have a equal to 1. Well, first we're going to review how to FOIL. And we're going to multiply out each one of these and simplify to see which one gives us x squared plus 24x plus 44. So for a, we get x squared minus 11x plus 4x minus 44. And when we combine like terms here in the middle, a negative 11x plus 4x does not give us 24x. And then here we have a minus 44, and we need a plus 44. So a does not give us the trinomial. When we check b, we get x squared plus 11x minus 4x minus 44. The middle terms here do not give us 24x. Again, here we have a minus 44. So b does not give us our trinomial. We'll try c. We get x squared minus 22x minus 2x plus 44. Our middle terms here give us a negative 24x. And we need a positive 24x here. We do have the plus 44, but we don't have the correct middle term, so c is not it. When we FOIL out in d, we get x squared plus 22x plus 2x plus 44. Now this time, our middle terms, when we add them together, 22x plus 2x, that does give us 24x, and then we have our plus 44. So D is our answer. That's the factored form of the trinomial x squared plus 24x plus 44. Now I'm going to write the simplified form of the trinomial, which is x squared plus 24x plus 44. And then the factored form, which is x plus 2 times x plus 22. And I want us to notice a couple things. X times x gives us this x squared. 2 times 22 gives us 44, and 2 plus 22 gives us 24 here in the middle. And when we factor, we're going to give you a trinomial like this, and you're going to come up with the trinomial in factored form, and it's just the reverse of FOIL. So for number 2, we want to factor completely, and we have a trinomial here, and all of the trinomials we're going to be dealing with, a is going to be equal to 1 when we use this method. So we want to look at this trinomial, and we want to look at c, and we want to think of two numbers that multiply together to be 15, but when we add them together here is going to give us 8. So we want to brainstorm a list of all the numbers that multiply to be 15 first, and we'll test to see which ones will add to be 8. Well, to get 15, I can do 15 times 1, or I can do 3 times 5. And I really can't think of anything else that would give me 15. I can see here, though, that if I add 3 and 5, I'm going to get 8. So there they are, and we can rewrite this now. We know x times x is going to be our x squared. 3 times 5 is going to be 15, and 3 plus 5 is going to be 8, our middle term. So now we've factored it. And we can always FOIL it back out to check. So we'll just double check here. X times x is x squared plus 5x plus 3x plus 15, and yes, indeed, those middle terms do add together to be 8x. So we have factored. In number 3, we're going to factor x squared plus 5x plus 4. So we're going to look for two numbers that multiply together to be c, which is 4, and then add together to be 5. Well, two numbers that multiply together to give me 4 could be 4 and 1 and 2 and 2. And when I add them together, it has to be 5. So it has to be 4 and 1 for that to work. So when I factor this, I'll rewrite it as x plus 4, x plus 1. Again, I could FOIL this out to check it, and I could get x squared plus x plus 4x plus 4, and we can see these middle terms do add together to give me our 5x here in the middle. So x plus 4 times x plus 1 is our factored form of x squared plus 5x plus 4. Another thing to notice is that the pattern here, we have a plus and a plus here, and then this one's a plus, and that's going to give us a plus and a plus inside of our parentheses as well. In number 4, we're looking for two numbers that multiply together to be 9, but when we add them together, it's a negative 10. So we can brainstorm our list for what gives us 9. We can do a 9 and a positive 1. Knowing that we're going to have a negative 10 when we add, we can also try a negative 9 and a negative 1. And then we could do 3 times 3, or negative 3 times negative 3 also gives us a positive 9. And of all those choices, the one that when we add together gives us negative 10 is going to be our negative 9 and our negative 1. So when we factor this, we'll write our two sets of parentheses. We know x times x gives us x squared. We know negative 9 times negative 1 gives us positive 9, but negative 9 plus negative 1 gives us negative 10. So here is our factored form. And in number 5, we're looking for two numbers that multiply together to be 10, but when we add them together gives us our middle term of negative 7. Well, what gives us 10 can be a 5 and a 2, or a negative 5 and a negative 2. We could do a 10 and a 1, or a negative 10 and a negative 1. And of all those choices, the one when we add together to give us negative 7 are going to be negative 5 and negative 2. So when we write this in factored form, we'll write our two sets of parentheses, our x times x, or x squared. Negative 5 times negative 2 gives us the 10, and negative 5 plus negative 2 gives us negative 7. So here is our factored form. Something to notice that in these patterns, when we have a minus plus in our trinomial and a minus plus, it's going to give us a minus minus in our parentheses and a minus minus in our parentheses. Now for number 6, we're looking for two numbers that multiply together to be negative 10 and then add together to be 3. And the more we practice with this, the easier it's going to be to find the two numbers right away, and we won't even have to write this down. Maybe you can see now that the two numbers are going to be 5 and negative 2, because 5 times negative 2 is negative 10, and 5 plus negative 2 gives me a positive 3. So when we write this in factored form, we'll have x times x is x squared, 5 times negative 2 is negative 10, and 5 plus negative 2 is a positive 3. For number 7, we're looking for two numbers that multiply to be negative 63, but when we add them together gives us positive 2. The two numbers that work there are going to be 9 and negative 7. 9 times negative 7 are negative 63, and 9 plus negative 7 is 2. So when we write this in factored form, we need our two sets of parentheses. X times x is x squared, and then plus 9 and minus 7 complete the parentheses, because 9 times negative 7 is negative 63, and 9 plus negative 7 is 2. Now go ahead and do numbers 8 and 9 on your own. Pause the video, and then come back and check your answers. Here are the answers to number 8 and number 9. Now for number 10, we're going to do the same thing. We're looking for two numbers that multiply to be 64 and add to be negative 16. And those two numbers are going to be negative 8 and negative 8. When we rewrite this in factored form, p times p is going to be p squared. And then we have a negative 8 times negative 8 is going to be positive 64. And a negative 8 plus negative 8 is a negative 16. Now we get the same thing twice. So we can rewrite this as p minus 8 quantities squared. And we notice that this pattern, where we get the same factor twice, is going to be called a perfect square trinomial. And they are always going to factor to be the same thing times itself. So go ahead and do numbers 11 and 12 on your own. Pause the video. Both of those answers will be of the same form as number 10. They're both perfect square trinomials. Here are the answers to numbers 11 and 12. And now when we look at number 13, we're trying to find two numbers that multiply together to be 2 and add together to be 1. And when I brainstorm my list, the only thing that gives me 2 when I multiply it together is a 1 times 2, or a negative 1 times negative 2. Although when I see the pattern of plus plus here, I know they both have to be positive. But neither one of these choices is going to give us a 1 when we add them together. So this trinomial cannot be factored. And what we say when it cannot be factored is that it's a prime polynomial. So not every trinomial is factorable. So in number 14, before we can factor, we need to rewrite this polynomial in descending order. And we do that by starting with the largest power first. So we have a 4x cubed, and then the next term is going to be a minus 28x squared, because that's the next one in line, and then 48x, so that our powers go down largest to smallest. After we've reordered it, we check to see if we can factor out the GCF being the greatest common factor. Well, all three terms are divisible by 4, so we can pull a 4 out of all of them, and they all have an x in them, so we can pull an x out as well. And we're left with x squared minus 7x plus 12. 4x times x squared is 4x cubed. 4x times negative 7x is a negative 28x squared. And a 4x times 12 is going to be a 48x. Next, we want to factor the trinomial that's in the parentheses. And to do that, we think back to what we've been doing earlier. We keep the 4x outside. We have two sets of parentheses. We know x times x gives us x squared, and we're looking for two numbers that multiply together to be 12 and add together to be negative 7. And those numbers are negative 4 and negative 3. So now we have factored this trinomial completely. Number 15, we're going to reorder this polynomial in descending order, so we're going to rewrite it as 3y cubed minus 18y squared plus 24y, highest power to lowest power. And then we're going to factor out the greatest common factor. We can pull a 3 out of every term, and there's also a y in every term. 3y times y squared gives us 3y cubed minus, and then 3 times 6 gives us the 18, and then another y, so y times y is y squared. And then we need 3 times 8 to be 24, and we already have a y. So there we pulled out the greatest common factor. Now we're going to factor the trinomial. So we bring down the 3y and we factor what's inside of the parentheses. Y times y is y squared. Two numbers that multiply to be 8. and then add to be negative 6 are going to be minus 4 and minus 2. So now we have factored this polynomial completely. Now we're going to factor the difference of two squares. This is a difference of two squares because the first term is a square, that's x squared. And then we have a minus, that's our difference. And then we have another square. 64 is 8 squared. And we're looking for two numbers that multiply together to be negative 64, but add together to be 0 because there is no middle term. And those two numbers are going to be negative 8 and positive 8. So we can rewrite this with two sets of parentheses. X times x is x squared. Negative 8 times positive 8 gives us a negative 64, and then negative 8 plus 8 gives us 0, which is our middle term. So go ahead now and factor the difference of squares in number 17 and 18. And then pause the video and come back and check your answers. Here are the answers to number 17 and 18. And when we look at number 19, again, we're trying to figure out what two numbers multiply to be 81 but add to be 0. Now this time, because we have a positive 81, we have just a positive 9 and a positive 9 that multiplies together to be 81. But we can't think of any two numbers when I add them together are going to be 0. They would have to be opposite signs to make that happen. This is also not a difference of squares because you can see even though m squared is a square and 81 is 9 squared, but we have a plus in the middle and it's not a difference of squares. So this one we cannot factor, and so we say that this is a prime polynomial.